Hi guys, today we're going to look at integrating between two curves. And so we'll have two different functions and there will be some distance in between them, and we want to find out what that area is. Okay, so we will be looking at it graphically, at least to give us an idea, but mostly algebraically. Okay, so kind of a sketch, I guess, is just a second. Okay. So, very basic sketch is something like this. And we'll call that f of x. So we just have a function. It'll need to be continuous. And then we might have this other function, g of x. Okay, and it will be below f of x. Okay, so f of x will need to be greater than g of x in each of our cases. Today we'll just look at where one function is always greater than the other function in the area that we're looking at. But Monday we'll look at where they can flip-flop. Okay, but so here we have function 1, here we have function 2, and we're going to be interested in the area between them. Okay, now sometimes these do go ahead and intersect, and so we can say from point to point. Sometimes they'll tell us a specific place to start and stop. It just all kind of depends. Okay, but again, our whole goal is to find out what is this area between them. Okay, now how do we do that? Well, it's all down to subtraction, because if you remember that when we integrate, that's just finding the area beneath the curve. So if I start with f of x, our big one, and then we take away g of x, which is underneath here, that will leave this piece here. Okay, so that's our actual theorem or our actual definition, and the full explanation or theorem is if f and g are continuous, okay, so we don't want any gaps, and it's on a closed interval AB. Okay, so if we are considering maybe this is A and this is B, okay, so on a closed interval, and like I mentioned, g of x needs to be less than or equal to f of x. Okay, so we have a higher function and a lower function. Then the area bounded by the graphs, or restricted, we could say, right? It's in between. And we are saying between A and B, okay? So between these vertical lines, A and B, between F and G. So if we have all of those bounds so that we're looking at a specific region, okay, then we get an integral from A to B. And like we mentioned, it's just f of x minus g of x, okay, times d of x. Okay, so it just is a subtraction problem with integrals in there. Now, sometimes we have to decide A and B, like I mentioned. Sometimes they'll give it to us. Sometimes we actually have to solve for it with quadratics. We could also graph, and I'll show you how to do that on Desmos, but it doesn't hurt us to refresh our algebra skills as well. Okay, the first thing I'd like us to do though is just look at a graph and see if we can rewrite some things. Okay, so this is my plan for your homework, is to start off with these as well. Okay, so we look at this one right here. Hopefully that's pretty clear for you. Okay, notice we do have two functions. They've told us f of x is x squared plus 2x plus 1. So even without this labeled here, x squared is a parabola, so we should know that's that lower curve. And then g of x equals 2x plus 5, so that's this line here. Okay, so they want us to find, at least write an expression for finding this pink area. Okay, and so we can start here, and I'll give you a look at it again. The things that we need to first identify is what's my left number and my right number for x, right? So where's that a and where's that b? So where do they intersect? Looks like they intersect at -2 and at +2. Okay, so that first piece of information that we're going to put in here is that we will need to go from -2 to 2. Now, we want to do our top function minus our bottom function. So our top function here, the greater function, is the line minus the bottom function. So we are going to have 2x plus 5 minus our lower function. Okay? And in this case, it was x squared plus 2x plus 1. Okay? And then of dx. So now we just need to simplify that in a step or two. So we get 2x plus 5 minus x squared minus 2x minus 1. Okay. And so the setup's the new part. Everything else is just doing like we have in the past. Okay, so here we get from -2 to 2. We get negative x squared. Your x's go away, and 5 minus 1 is 4. Okay, so this simplifies into finding the integral from -2 to 2 of negative x squared plus 4 dx. So these first couple and the first couple tomorrow, I just want you writing the equivalent integral, or the integral that would help us find out the area if we want it. Okay, so let's look at another one, give you a chance to maybe glean some information. Okay, so we need again a left and right. Okay, limit. So it looks like they intersect at 0 and they go to 1. And so that's the first thing we need. Sorry for the whiplash notes here. Okay, so from 0 to 1, and then we need to take our high function minus our low function. And here it says we have f is on top and g is on bottom. And you can't see it here, but f is x squared and g is x cubed. So it's f minus g. So we just get x squared minus x cubed dx. Okay, and this one doesn't have any simplification possible. Okay, so some of this is just practicing reading from a graph. Okay, so let's go ahead and jump to one that we actually are going to solve. Okay, let me find my notes. So let's say we have y equals x squared plus 2 and y equals negative x. Okay. So we should know that this is a parabola and that we have a line. And this one actually we could graph probably without Desmos if we were to think about it. Okay, x squared plus 2 is just our parabola that's been moved up 2. And so it's doing something like that. Okay, and then the negative x is a line that passes through the origin with a slope of -1. Okay, so it's doing something like that. Okay, so we're concerned about the area in between here. Okay, and in this case, they actually tell us we just want to go from 0 to 1. Okay, so they give us that information. So let's go ahead and see what we can do. Looking at this picture, we know our limits are 0 to 1 because they told us that. Who's on top? Well, that's our x squared. Okay, so we're going to take this minus this. Okay, so let's just use our formula now. We're going to go from 0 to 1, and we know our top one is at x squared plus 2. We want to do minus x dx. And now we actually want to find that amount of area in between. So we have to go ahead and integrate this. So we get x cubed over 3 plus 2x minus x squared over 2. All of those come from that power rule, and we want to do it from 0 to 1. Okay, so there will be no c's on these because we will be integrating them from specific places. Okay, so now we plug in 1. So 1 cubed over 3 plus 2 times 1 minus 1 squared over 2. There's no need to put in 0 because these all have x's in it, so it knocks those terms out. So we end up with 1 cubed plus 2 minus 1/2. Okay, so if we were to put that all together, I think I missed a sign somewhere. Oops. Okay, I apologize. I messed up here. So x squared plus 2, and we need to subtract the negative x. Sorry about that. So that becomes a plus x. I should have changed signs there. So that becomes a plus, and that becomes a plus, and that becomes a plus. Okay, so I apologize for that. So here we have 2/6 plus 3/6 is 5/6 plus 2. So we get 2 and 5/6 for our answer. Okay. So that's just representing the area in between the two equations. Okay, so let's try another example. Okay. So we get f of x equals 2 minus x squared. So here we have another parabola, and it's upside down because that's negative. And then we have g of x equals x. Okay. So again, we could figure this out just with our graphing knowledge, but let's go ahead and just go to Desmos a minute and see what we can find there. Okay, so let's see if we have 2 minus x squared, and then we have x. Okay, and so you'll see that these intersect, and this time on the left it looks like they intersect at -2, and then they go to +1, and it looks like our x squared is always on top. Okay, so oh, sorry, I guess you never got to see that. Let me see what happened. There we go. Okay, so sorry about that. See, the quadratic is on top, and then the line is always down below, and again they intersect at -2 and +1, and so that will be our limits. Okay. So I will try not to forget to bring you along next time. Okay, so we had something like that, right? And it doesn't matter, but just kind of give ourselves a sketch. And we said it went from -2 to 1. Okay, so it's great to have Desmos to tell us that, but what if we did not have Desmos? Okay, well, what we have to do is we set these equal to each other. So what if we didn't have our graphs here and we couldn't get our left and right numbers? All we have to do is set these equal and solve. So 2 minus x squared equals x. Move everything to one side since we have a quadratic. So we have x squared plus x minus 2. And then if we factor, this is x plus 2, x minus 1. So x equals -2 and x equals 1. And so those are the two x values where they intersect. And so that's what we would be using here. Okay, so here's with Desmos and here's algebraically. Do I care which way you do it? No, but just make sure you know how to find it. Okay, so now we're ready to put this into a integral. So we're going from -2 to 1, and we want our top function to be first. So we have 2 minus x squared minus, right? And then that second one is x. Okay, of dx. you do at least have graphical knowledge, right? Which one is on top. So it's not a bad thing to graph in your calculator or on Desmos by any means. So here we get 2x minus x cubed over 3 minus x squared over 2. If we do our integral, and then we have from -2 to 1. Okay, just quick check that I have my signs right. Now we go plug in the 1. So 2 times 1 minus 1 cubed over 3 minus 1 squared over 2. Okay. Minus, if we put the -2 in, 2 times -2. I got kind of squished here. So 2 times -2 minus, let's see, -2 cubed over 3 minus -2 squared over 2. So a good place to mess up with our negatives, but let's see what we get. Okay, I apologize for not being very organized on writing this out. So we get 2 and minus 1/3 minus 1/2. And then 2 times -2 is a negative, but I have a negative out here, so that's plus 4. And then we get a -8 over 3, but there's a negative here, so it turns it into 8/3, but then we have that negative there, so -8/3. Okay. And then we have -2 squared is positive, but here's a negative, but that makes it a positive here. So we have 4 over 2, which is 2. Okay. So I have 2 minus 1/3 minus 1/2 plus 2 plus, 2 minus 1/3 minus 1/2 plus 4 minus 8/3 plus 2. I was just checking my previous work. Okay. And so these all make 4.5 together. So what we just found is that there's 4.5 units in between these two functions. Okay. So let's try one more, at least. Okay. What if they give us the function f of x equals 3 minus x squared minus 2x, and g of x equals 0. Okay, here we have a quadratic again. It is upside down, we know that because of this. And g of x equals 0 is just this y equals 0 or x-axis. Okay, so we know we have an upside down parabola. Again, we can use Desmos to go see what it is. So let's go over there a minute. And we can plug that in. We can plug in 0. And we can plug in, well, 0 equals y. Oops. Maybe not. Okay. 0 equals y. And then we can plug in 3 minus 2x minus x squared. Okay. And so we can see that it goes from a -3 to a +1. And we see that the quadratic is always on top. Okay, which shouldn't surprise us since we knew this was upside down. Okay. So let's go back here. We had something like this, and what, -3 to 1. Okay, so again, we're just trying to find this. Now, how could we have done that without Desmos? We just plugged this equal to each other, and that's ready to solve. Okay, we would have factored it, and we would have gotten our zeros to be 1 and -3. Okay, so let's go ahead and integrate. We said our quadratic is on top. And when I do f of x minus g of x, well, subtracting 0 doesn't change anything. Okay, so it just ends up staying this way. And we said it went from -3 to 1. Okay, so if we integrate this, we get 3x minus x cubed over 3 minus 2x squared, okay, from -3 to 1. Okay, and that simplifies to 3x minus x cubed over 3 minus x squared. from -3 to 1. Then we just plug in. So 3 times 1 minus 1 cubed over 3 minus a -3 squared. Sorry, I don't know why I jumped right there. So 3x minus 1 cubed minus 1 squared. Okay. Minus, and then we plug in our -3. So 3 times -3 minus -3 cubed over 3 minus -3 squared. Okay. So then we get 3 minus 1/3. Let's see, -1, that's a positive 1. Okay. 1 squared is 1 with a minus, we have a -1. 3 times -3 is -9, and we have a negative out here, so that's +9. -27 over 3 is -9, but that makes it a +9, but that makes it a -9. And then -3 squared is 9. But this is a negative, so that's -9, but that makes this a +9. So lots of 9s everywhere. That makes 0. And here we have 8, and this is 11. So we have 11 minus 1/3. So we get 10 2/3, or 32/3. Okay. So that is how you find the area between two chords and, two functions. And if you have any questions, please let me know.